we're looking at Newton's second law of motion. So Newton's first law has to do with scenario wherein the net force is 0, and this is a scenario wherein the net force is non-zero. So we have Newton's law answering the question of what happens to an object that has non-zero resulting force acting on it. Right? That's the basic idea. That's what Newton's second law helps us with. Okay, to understand Newton's second law better, I have two quick questions for you guys. So please pause and have a look. Answer the question. Okay, so there are 1, 2, 3. One or guess the acceleration. My bad. So this is the case 1, case 2, case 3. Case 1, case 2, case 3. The question is we need to figure out the acceleration in case 2 and case 3. And here, same over here. So in the first case, let me explain the scenario. The mass is same. The force are different. You need to tell which will have what kind of acceleration. If this is A, the acceleration over here will be, what will be the acceleration in case 2? Okay guys, so my question was, this is the mass, same mass in all of these three cases, but the forces are different. If the acceleration in the first case is A, the second case the acceleration will be what? It will be 2A. In the third case, what is the acceleration? It will be 3A. Why? The force is increasing from F to 2F, so the acceleration will double. Here the force is increased from F to 3F, so acceleration will double. It's common sense. If I am able to move an object with a particular acceleration, that is, the velocity keeps changing at this particular rate. If I push more, it will accelerate more. It will go faster and faster. The rate at which the acceleration velocity changes is faster. And if I triple it, it will also triple. Now, I already have a force of F for all the three cases, but the masses are not the same. For the first case, acceleration is A. For the second case, acceleration will be 2A. Is this correct? No, it will be A by 2. But why A by 2? And what about third case? It will be A by 3. Why is that? Obviously, right? If I have a person who is, say this is a kid, with mass M, we'll be able to push the kid on a chair or something with certain acceleration, with certain amount of force, and so on and so forth. So the kid will go faster compared to a person, or say two kids sitting on the same chair, and you guys pushing with the same force. Obviously, the object will accelerate slowly. Does it make sense? So what can you conclude from these two discussions? When viewed from the initial frame of reference, the acceleration of the object is it directly proportional to the net force? Yes, it is directly. Why is it directly? Because as and when the force increases, your acceleration also increased. And so there is a direct proportion between them. Or acceleration is directly proportional to force is the funda. Right? Directly proportional means when one increases, the other increases as well. While net force acting on it and dash proportional to its mass. Inversely proportional to its mass. Acceleration is inversely proportional to its mass. You guys agree? Okay. Next, let's move on to the mathematics of Newton's second law. So mathematically, what is that we are looking at? So mathematically, what it tells is math view of second law. Mathematical view of second law, actually, that would be a better heading. The net force on a given object is equal to mass times of its acceleration. So this is your net force and your acceleration, but there is only one acceleration. There can be many force on an object, acting on an object. I can have it pushed in so many different ways. But end of it, it might accelerate somewhere in this direction, for example. Okay, the net force can be over here. And so the acceleration will be in this direction only. Basically, it means that the object can go only in one direction, right? It can't go in all the directions. That's all, nothing else. Nothing fancy happening over there. Now, let's state your Newton's second law. The rate of change of momentum of an object is directly proportional to the external force applied on it. Also, the change in P takes place in the direction of the applied force. That is, if we happen to have an object whose net force is to the right, our momentum will change, or the direction of momentum, or let me put it this way. First is our acceleration will be in that way, and also here we can see the statement, the change in momentum takes place in the direction of applied force. So change in momentum will also be pointing towards the direction of the force. Okay, then what else? Above statement in free body diagram. So this is good enough for now. Next, let's move on to force in the direction of motion. Force opposite to the direction of motion. What is this about? Oh, okay. Free body diagram for both the cases. Sorry guys. So this I already drew. Say it already had an initial velocity of u. It would be something like this. And let me do the other. The second case is the force in the opposite direction of movement. Say an object is moving to the left. Now you apply a number of force and the net force is to the right. The direction of acceleration will be to the right and the direction of momentum will be to the right. Okay, that's all. So this is what we are trying to tell. Even though the object is moving to the left, right, doesn't mean the change in momentum has to point towards the left. Okay, so this you will understand with numericals and everything. It's actually commonsensical also, but let me go step by step. Okay, for now, I think this is just a small introduction. Let me not go into this anymore. I'm here right now. We had a look at Newton's second law of motion. The law deals with what happens to the object when it experiences a non-zero net force. So what happens? The acceleration changes. So if the mass is same but you have different force, or you can think in this way, if you have an object, if you're pushing with certain force, if you increase the force, it will accelerate more. If you decrease the force, it will reduce the rate of acceleration. It will reduce the acceleration basically. It will reduce the rate of change of velocity basically. Anyways, that you guys know of. And if you have the same force acting on different masses, the one with the lighter mass will accelerate more, one with the highest mass will accelerate less. So acceleration is directly proportional to force, acceleration is inversely proportional to mass. And as a conclusion, this will be your statement. And mathematical statement of Newton's second law looks like this, whatever we just saw. The net force is equal to mass times of acceleration. Even though an object can experience many forces, the net force and the acceleration is always only one quantity. One important note, the direction of change in momentum is always in the direction of the force applied. Even though the object is moving in the same direction or the opposite direction of that of the force, it doesn't matter. The direction of change in momentum remains the same. Okay. So yeah, you guys have to start writing from here. Direct and inverse. Mathematically, it looks like this. Change of momentum does not depend on the present velocity.